We're looking at the series n squared plus 1 over n cubed minus 1, and we're trying to figure out if this series is going to converge or diverge. One of the things that we might notice when we're looking at this series right off the bat is that if we kind of squint our eyes a little bit, get rid of those pluses and minuses of ones, this is almost n squared over n cubed, which reduces to 1 over n. So this is going to be very important, right? We know what happens to the summation of 1 over n. This one is divergent. So this tells us that maybe we want to do some sort of comparison to a series that we are aware of, which brings us up to the limit comparison test. So in the limit comparison test, we have two series, AN and BN. They all have positive terms. Good. We've got that with our particular summation right there. If the limit is of AN over BN gives us some value C, where C is a finite number, it's got to be positive, then they're either going to both converge or diverge. So the idea is compare it to something that you do know what happens, and in this case, we know that the summation of 1 over n diverges. So if we can get this limit here for an over bn to be bigger, equal to some number bigger than 0, we know that we have our answer and the series that we are looking at will diverge. All right, so let's actually put this into action. We are going to take the limit as n goes to infinity, and we want to put our series on top, although it really doesn't matter, n cubed minus 1. And the series we want to compare it to 1 over n on the denominator. All right, one of the nice things, keep in mind, always a good tip, if you've got a fraction divided by another fraction, all you have to do is flip and multiply. And if you like hints like this, subscribe. Okay, so this is going to give us the limit as n goes to infinity of n squared plus 1 divided by n cubed minus 1 times n over 1. And I'm going to put parentheses around here because what we're going to do is we are going to distribute that n into the top, the numerator of our fraction there. Once we have that, we have n cubed plus 1 divided by n cubed minus 1. And notice as n gets big enough, that plus and minus 1 is going to matter less and less. In fact, it's not really even going to matter that much at all. It just does not impact our limit because everything else dominates. So we have our n cubed 1 minus 1 over n. That should be a plus n. I apologize that. And this should be an n squared then. There we go. And now we can cancel our n cubes. And that should also be a plus. There we go. But it really doesn't matter because as n goes to infinity, this goes to 0, this goes to 0, and what we are left with is 1 divided by 1, which is positive 1, a number that is bigger than 0 and finite. So by the limit comparison theorem, our series of n squared plus 1 divided by n cubed minus 1 diverges. All right, thanks for listening.